Alright, in this video I just want to go over how to find limiting reactants and how to work the problems. So on this question, it says you have 80 grams of copper and 25 grams of sulfur, and it wants to know the greatest possible number of grams of copper 1 sulfide that can be formed. So the easiest way to do limiting reactant problems is just to go ahead and take both amounts that they give you and convert them both into product. So first step is always to convert to moles. So this is 3.5 grams in 1 mole, 32 grams in 1 mole. Then don't overdo it. So we got 1 mole of the copper 1 sulfide to 2 moles of copper. That comes from the balanced equation. Down here it's 1 mole of sulfur to 1 mole of the copper 1 sulfide. And then when you are finishing up, 1 mole is 159 grams. So when you're working this out, just do it like normal. You'll get 100 grams on top. And on the bottom, I think you will get 124. And so, looking at the results here, you only get 100 grams up top. That means that copper is your limiting reactant, and this is the maximum amount you can make. The copper limits how much you can make because it is the one that will get totally used up. All the copper is going to be used. You'll have some sulfur left over, but every bit of the copper will be used. So, I got that right. On this one, this is where I showed you the shortcut. So this one I asked you to identify the limiting reactant. Don't use the shortcut unless you really feel comfortable with it. It's really easy just to take both amounts, convert it to product, and figure it all out there. But if you want to, you can look at the mole ratios. So in this reaction, we have a 1 to 3 ratio between ethene and oxygen. So that means for every 1 mole of ethene, you need 3 moles of oxygen. Well, they give us 2.7 moles of ethene. So, how would you figure out how much oxygen is needed for that? Multiply 2.7 by 3. If you do that, you will get 8.1, which means that you need 8.1 moles of oxygen to totally react 2.7 moles of ethene. Do you have that much? Well, no, we don't. We only have 6.3 moles of oxygen. So that means oxygen is the limiting reactant, and we're going to have excess of ethene. So the limiting reactant is oxygen there. You could also have done it the opposite direction. If you look at how much oxygen you have 6.3 moles of oxygen. So if it's a 1 to 3 ratio between ethene and oxygen, divide 6.3 by 3, you get 2.1 moles of ethene is needed to completely react this much oxygen. Well, do you have that much? Yes, you do, and more. So ethene is in excess, oxygen is limiting. So both ways works. You just have to kind of use your mole ratios there and figure that out. On this one's a little bit more difficult, but not much. You have your mole ratios. This one's a 2 to 5. So instead of just looking at, multiplying or dividing by a whole number, you'd have to look at the mole ratio. So once again, the easiest way to figure out how many grams of water can be produced is to do 2 separate problems. You do the 2.4 moles of ethene and the 7.4 moles of oxygen, and then you would, don't overdo it, go to grams of water. Whichever one makes the least water is a limiting reactant, and it tells you how many grams of water can be produced, the maximum amount. With the shortcut, what you want to do is pick one of these and convert it into the other one. So if you pick ethene, or ethylene, acetylene, you would have 5 moles of oxygen on top 2 moles of ethene on the bottom. So when you multiply 2.4 times 5 over 2, you get 6. So that means you need 6 moles of oxygen to totally react all of this. Well, do you have that much? Yes, indeed. You have more than enough oxygen. So oxygen is excess, ethene is the limiting. So now what you'll do is you'll go ahead and just use the ethene and convert that into water. So if you have ethene, 2 moles of ethene to 2 moles of water, we'll get that from up here. Then 1 mole of water is 18 grams of water. And then that's it. You just solve the problem, and your answer is 43.2 grams of water. So I think that's all I wanted to talk about on this little bit. There's problems like this where you have to convert from grams to moles and liters to moles and then solve. But it's all the same process. Take what is given you, convert it to moles, then do the don't overdo it step, then convert to whatever you're looking for, which will be some form of the product typically. It's not always going to ask you what the limiting reactant is. A lot of times it's going to ask you how much product was produced. So in those situations, just convert to product. The smallest number will tell you how much you made. It will also tell you which one was the limiting reactant. If you want to use the mole ratios, that's fine. Don't feel attached to that. Do whatever's best for you. So good luck, and I